Hello everyone. So today we're going to talk about higher order derivatives. So here's my big question to you guys. Do you think we can take the derivative of f prime? Or in other words, do you think we can take the derivative of the derivative function? And so the answer is actually yes. Okay, we can. And so below here I have some notation for higher order derivatives. Okay, so on the left you see that we have Newton's notation. Right, so of course we know f prime of x is the first derivative, right? For the second derivative, we say f double prime. And then for the third derivative, we have this notation here where we get these like parentheses and then write the number. Okay, because here, that's what you're seeing at the bottom is the nth derivative. So no matter what my n is, as long as it's bigger than 2, right? Because for the first derivative, we put a tick mark for the f prime of x, and then the second derivative, 2 tick marks for f double prime. But then anything bigger than that, we really just use those parentheses and then write the number in for the third derivative, fourth derivative, so on and so forth. Okay, and then here on the right, we have Leibniz notation, okay, for higher order derivatives. So we're already familiar with dy dx, which just means take the derivative of the function y with respect to the x variable. Okay, so here you see that I define the function f of x as y equals f of x. So we can understand that we're talking about y being our function in the numerator. So again, take the derivative of y with respect to the x variable. That would be the first derivative. And then as it gets higher up for the second and third derivatives, you see how they just get this 2 here and then this 2 here, indicating that we're talking about the second derivative. And then for the third derivative, same idea, just now using 3's and so on and so forth. Okay, so let's do an example. So it says, suppose that my function f is equal to x to the fourth plus 6x squared plus 7. What's the third derivative of f of x? Okay, so first I want to just compute the derivative function. Okay, because if I want to find the third derivative, all I really do is I compute the first derivative, and then once I get the first derivative, I take the derivative of the derivative function to get the second derivative. And then to get the third derivative, I take the derivative of the second derivative. Okay, so you'll see what happens here, but that's all that's really happening. All right, so let's first just take the first derivative of the function. So this is x to the fourth, the derivative of x to the fourth, plus the derivative of 6x squared, plus the derivative of 7. And so this gives us 4x to the third plus 6 times the derivative of x squared plus 0. And so ultimately this is just 4x cubed plus 12x. Right, bring down the power of 2, subtract 1. Okay. So now what I'm going to do is now I want to find the second derivative. So what I'm going to do is look here at my first derivative, which is 4x cubed plus 12x. And now I'm going to take the derivative of this function. So I'm going to say that the second derivative, is the derivative of the first function, which is the derivative of 4x cubed plus the derivative of 12x. So this gives me 12x squared plus 12. Okay, but now I want to find the third derivative. So now I'm looking at the second derivative, and to find the third derivative, I just take the derivative of the second derivative. So the third derivative is going to be the derivative of 12x squared plus the derivative of 12. And so this gives me 24x. And so this is my answer. Oops.